This is Freeze Key, the last challenge in Act 3 before the big final challenge. This one is also a challenge that was meant to be, I think, for a tougher objective and tougher challenge, but you can basically shortcut it with an LLM tool. Let me show you what I mean by that. So this challenge starts off with the retro computer shop. We need to talk to Olivia, and you can see that the difficulty level of this is 5 snowflakes. I was really concerned about this one because it is a reversing challenge, but it's fine. It's actually fine. So we get hints along the way. You don't necessarily have to follow those hints. There are, I think, easier ways as well, based on, well, what I got from the Claude AI tool. So you need to talk to Olivia in the retro store. And it is about basically playing a game. This game does not run out of the box. I think it's missing some sort of image. I'm pretty sure you can fix it if you want to, but you don't have to actually play the game or run the executable. So if you get to the hints, I think there's 2 or 3 hints for this one. One is mentioning, have you ever used PyInstaller Extractor? So this is a reference to PyInstaller Extractor. You can just also install this, I think, using pip, but this works too. And I mean, cloning the repository works too. And the other hint is on decompile++, which works to some extent, and I did use this one to, well, again, some extent. Apparently this is not even necessary. So this promises to decompile the Python PyC bytecode, but it fails. And later I actually found a branch that works, but we don't even need that. So that's it. You have to check your items, I believe, and you will have the Freeze Key exe. So this is an executable. You can download it from this link here, and then you're off to the races. If you follow the hints, the PyInstaller Extractor is the first thing. Okay, I already have this one downloaded here on my system, and in the directory I placed the Freeze Key application, which is kind of chunky, so it's 17-ish megabytes, and the PyInstaller Extractor is going to give us the PyC code. So if you run Python PyInstall Extractor Freeze Key exe, it is going to create this Freeze Key exe extracted folder, and within that folder, let me just clear the screen here, we are going to see Freeze Key PyC, and that's the file that we need then for the decompile++. So I try to find it here. That was the second hint, basically. Bits and bytes, maybe? Is that the one? No, that's the previous challenge. Okay, it's one of the hints. I don't know now. It's kind of hard to. There's a way to search in the objective. So let's try Freeze Key. There we go. Okay, so decompilation would be the second one. So decompile++ will do a pile assembly version, and you can also try to decompile it and kind of reconstruct the Python code. That one fails. Just like spoiler. And for getting the PyASM code, you don't even need this tool. You can just do it with Python. But I quickly want to show you what you can do with this. So I have a Kali box sitting here. And if you go to the repository and clone the repository, just do that one very, very quickly. Paste. You can use this tool still for getting the decompiled code, and that's what I did. But later, the Claude AI tool told me that I don't even need that. We'll check it where it mentions it. And you need to compile this, so you need to do cmake. Why is it not? Okay, weird. Oh, cmake is not found. Okay, let me just install quickly the dependencies then. Let's start with an apt update here. So we need a couple of tools for this one, like cmake, make, and I think also G++. This is something that I asked from Claude. They told me like, hey, when you want to run this tool, run this first. So these are dependencies. Apparently only cmake is missing. We should be able to run this one in a second. And again, normally this is something that we should be able to do. That's why it was not tab completioning for me, but we should be able to do the same thing with Python. And then we make the program. Let me just see, because it was mentioned at some point. So we're gonna run it like this. Yeah, this is really not necessary here. And then later you will see that it actually explains me. Where did I had that one? There we go. So you can disassemble it natively. It's using the this library. So you just basically read the PyC file, and using this, you just provide it with the bytecode, and it will do the disassembled code for you. So this is an alternative way of doing it. But you can also use this tool. And we have now PyC DAS and PyC DC for decompiler and disassembler. I'm gonna drop these ones in my local bin, and we should be able to. I already moved the FreeSki file here. Hopefully, oops, not here, but here. FreeSki, what is it doing? We got FreeSki Py. And to get the disassembled code, we just need to run a PyC DAS for disassembler. We provide the PyC code and output the results into the PySM file. And let me just do a bit more, like let's do -200 lines. You can see that this is now a disassembled code from the PyC bytecode. And this is going to be a struggle, right? So no one actually wants to look at this. And probably a lot of people who try to solve this tried the decompiler instead. The problem is that you get a warning, and after a couple lines of decompiled code, this fails, and it actually fails miserably. These are, by the way, the images that I think are missing. So when you try to run the executable, it doesn't work. And there is this make function, unsupported opcode error message here. I tried to search for this. There are forks that attempt to fix this. I also asked Claude, what can I do? Is there an alternative? And after a while, I just gave up and said like, oh, well, then let's work with the disassembled PySki PySM code. And I, again, took a shortcut here. So I provided the PySM code to Claude and then the hints and the description. This doesn't do much actually. And I said, hey, get the flag, write me a solver program and explain how the FreeSki program works. And it did it. And it did it actually on the first go flawlessly, extracted the flag with the code. I also have the Python tool on, I don't have it on the desktop, but I will have the PySolver in a second on my desktop. And I can go to C colon, get to my desktop and use the, oh, no, that's Python for data science, Python FreeSki solver. And on Mount Snow, it finds the valid flag. Now, but how does it work? So we have these treasure values and you can see here also the quick explanation. I'm not going to take credit for it. I just asked Claude how it works and this is a short explanation. So apparently there's a random number generator, which is always seeded by the mountain name. And the mountain name is the seed for the random treasure locations, apparently not so random locations. And then the flag decryption is seeded by the treasure value. So this is all deterministic and you can just, based on the seed values, calculate the location of the treasures. And when you have all the 5 treasure positions correctly determined, then the set flag function is going to provide you with the flag. Now you can see here that we have some gibberish for the others. This is because, well, depending on how you seed it, it will give different results, but this is the only one that gets back with a valid flag. So basically the hardest part of this challenge is to get to the disassembled code, which is, well, not difficult at all, apparently. And the rest, you can just leave it to an LLM tool because they understand PySM probably much better than you and I ever will. So again, I think here the challenge should be probably closer to 2 snowflakes tops. I would say to some extent this was easier than the on the wire one. So let's just submit it and we unlocked this no blind ambush final challenge. This one is a tough one though. So I know that this is kind of anticlimactic for a 5 snowflake challenge and again, it might feel like cheating, but this is a CTF game. If you play a CTF game, your goal should be to score as fast as possible. And I believe that this is hands down the fastest way to get the objective done. Of course, you can analyze the PySM code and learn something new. But let's be honest, like in a real life situation, you probably wouldn't necessarily do that. Or at least you would check what the LLM tool has to say about it. And yeah, here the solution required you to get to a specific end result and then check that end result. So I know that some people would like to see a lengthy video on this, but I'm not gonna do that because I don't think this is realistic. And thinking back the past year, can't really remember scripts that I wrote the old-fashioned way. I had to sometimes correct them, and you will see in the next one that these LLM AI tools are not limitless. There is a limit, and sometimes you have to jump in as human and fix a couple lines of codes, but this is orders of magnitudes faster than us humans can like analyze and write code, and they're perfect for this. Now, other parts of the challenges, it failed miserably, by the way. So coming up with a payload, I had to like give nudges for the bypass, as you will see it on the next video. So yeah, this has been already plenty of time spent on this challenge. Let's move on to the final challenge in the next video.